Hey, Mr. Richards here. Today's 6th grade, Unit 6, Lesson 5, Anchor Problems. The following two diagrams represent the equation 2x equals 8. Explain how you can use each one to find the value of x. Well, what I see here are 2x equals 8 because there's 2x equals 8. These are two equal parts. And so if I were to take 8 and divide it by 2, you get 4. And so this x is equal to 4, and this x is equal to 4, and sure enough, 4 plus 4 is 8, so 4 is our solution. Here, you also have two x's and 8, and something special can kind of happen. If I break this 8 into two equal groups, I have this group of 4 can go to this x, and I have this group of 4 can go to this x, and so each of these x's gets 4. Now, let's look algebraically what happens here. If I have 2 times x equals 8, very similar to how we solve equations with adding and subtracting, we're looking for the inverse or opposite operation. And so the opposite of multiplication is division. So if I divide, writing it as a fraction bar when we solve these things, divide by 2 on both sides of the equation here. 2 divided by 2 is 1. So we're just left with 1x, which is exactly what we want to be left with, just 1x. Then 8 divided by 2 is 4. And so can we use that to solve 3 4/10 m equals 13 6/10 without using a diagram? Of course. The opposite operation of multiplication is division. So we'll divide by 3 4/10 on both sides. 3 4/10 divided by 3 4/10 is 1. So we're left with 1m, which again is exactly what you want. And 13 6/10 divided by 3 4/10 is 4. And similar to adding and subtracting, could you put your answer back into the equations and see if you're correct? Sure. 2 times 4, that's 8. 3 4/10 times 4, that's 13 6/10. Let's move on to problem 2 and see, well, this is a little different. Complete the tape diagram below to represent the equation x divided by 5 equals 10, and then use it to find the value of x. Well, let's divide this x into 5 groups. 1, 2, 3, 4, and they're supposed to be equal-ish groups, close enough. Now, to use it to find the value of x, when I took x and divided by 5, each of these was worth 10. Well, what's my total? 50. So when I took 50 and divided it into 5 groups, I got 10. Well, okay, we're going to need to look to solve this without a diagram, so let's take a peek. This is x divided by 5 equals 10. Well, in question 1, the opposite of multiplication was division. So same concept. The opposite of division is multiplication. So if we multiply by 5 on both sides here, 5 cancel out to be 1. So you're left with x equals 50. And sure enough, if you substitute 50 back in for x, 50 divided by 5, that's 10. Can we follow something similar here for p divided by 6 equals 9? Sure. The opposite of division is multiplication. So if I multiply by this 6 on both sides of the equation, this cancels, and we're left with p equals 54. And sure enough, 54 divided by 6 is equal to 9. And so we're still, just like adding and subtracting equations, using the idea of opposite or inverse operations. So let's go on to some questions that have fractions, because those are always fun. 3 equations are shown below. For each one, identify all of the ways that an equation could be solved. 1a, we have 1/5 x equals 15. Let's rewrite this down here. 1/5 times x equals 15. Well, so far, all I've shown you is you use the opposite operation. So the opposite of multiplication is division. So when we divide by 1/5 on both sides here, 1/5 divided by 1/5 is 1. That cancels, and we're left with x equals 15. I'll rewrite the division here as a division sign for that way. 15 divided by 1/5. And here we go. B, x equals 15 divided by 5. That's 1/5. That 5 and 1/5 aren't the same. There's no mistake here. So, well, let's keep solving it, right? Because normally, if you're dividing by fractions, you have to take x equals, change the division to multiplication, and flip the 1/5 to 5 over 1, which is 5. There it is in A. X equals 15 times 5. Interesting. So we divided by 1/5, but we ended up multiplying by 5 to get our answer. Like 5's the reciprocal. I wonder if that works for more questions. Let's go to B. We have 3/5 times x now still equals 15. And again, for the most part so far, I've said just divide by the number here, the opposite operation. So we'll divide by 3/5 on both sides, because 3/5 divided by 3/5 cancels out to be 1x. And so just 1x is equal to 15 divided by 3/5. And this time the answer does exist. It's here at C, 15 divided by 3/5. But here I had to change flips. Let's see if we get a similar answer here. If I were to keep, change, and then flip 3/5 to 5/3, 15 times 5, oh, there it is, 15 times 5/3. So, we're dividing by 3/5 here, but we're also multiplying by 5/3. Let's look at one more, at least. 2/5 times x equals 4/15. And again, if we divide by 2/5 on both sides here, what ends up happening is 2/5 divided by 2/5 is 1. And we're left with x equals 4/15 divided by 2/5. And it does exist here in C. X equals 4/15 divided by 2/5. But let's keep change flip again. X equals 4/15 multiplied by the reciprocal here, 5/2. And once again, here it is in B. Something's going on with these fractions, huh? Looks like we can do something a little different to solve these questions. And I'm going to give you some bonus examples here. So if you're going, where are these? Where are these? They're kind of coming out of my imagination. So if I have something like 1/2 x equals 4. Half of what is 4? If I just asked you that, half of what is 4? And hopefully you'd say half of 8. But if you were to solve this question by dividing by 1/2 on both sides first, you could, because 1/2 divided by 1/2 is 1, so that cancels, and you're left with x equals 4 divided by 1/2. But here's the thing, when you're dividing with fractions, you end up multiplying by the reciprocal, the flip. So x equals 4 times 1/2 flipped is 2 over 1, or just 2. And 4 times 2 is 8. Now, what happens then if I had 1/2 x equals 4, and instead of dividing by 1/2, what if I jump right here first and go, well, what if I multiply by the reciprocal? What if I multiply by 2 over 1 first? Why does this work? Well, what's 2 times 1? 2. What's 1 times 2? 2. What is 2 over 2? 1. The whole purpose of dividing here was to make this 1x, because 1/2 divided by 1/2 was 1, and on earlier questions, 5 divided by 5 was 1, and so on. Well, if these fraction questions, if I can just multiply by the reciprocal and have the same result, might as well just do that. I'm left with here x equals 8. Now, what about more complicated questions like 2/5 x equals, we'll go, trying to think of a fun number. Let's do 9/10. Okay, if it's 9/10, the way I'd like you to approach these, if you have a fraction here with the variable and its multiplication, instead of dividing, multiply by the reciprocal instead on both sides. Again, you're not going to have to write this part out, or what I'm about to write up here every time. Just wanted to show you why this cancels out. 5 times 2 is 10. 2 times 5 is 10. That's 1. This cancels. That's what you want. You want just a single x. Equals. And can you cross simplify with multiplication? Sure. Divide by 5, divide by 5, you get 2 and 1. And so x equals 9/4, and that's fine as an answer. And remember, any equation question you could check. You're like, I don't know if I'm right. This looks kind of goofy. 2/5 x equals 9/10. Substitute in our answer. So 2/5 times 9/4 should equal 9/10. And if you didn't cross simplify, you'd get 18 over 20 equals 9/10. You're like, aha, I'm wrong. No, you're not. Divide by 2 on top and bottom here. And you get 9/10 equals 9/10. And so instead of dividing both sides by a fraction here, what I'm trying to get you to see is if you multiply by the reciprocal, it's going to be so much easier if you look at that and do it right away, because you're going to end up multiplying by the reciprocal anyways. So you might as well do it early on. That's it for this lesson, 6th grade, Unit 6, Lesson 5. Good luck.